All right, welcome to the final day of the Yoga PTG for the Cinder sessions, and I guess for everybody, actually. Um, so I rearranged the schedule. I sent out an email. So we're going to kick things off with Gorka's discussion of what he wants to do about the quotas. And then we're going to go over to the TC to get in on the discussion about secure RBAC, which they've got scheduled for 90 minutes. And with the more people you got in something, the longer it goes. So we may be there for 90 minutes. I don't know. So we'll have to go to Zoom to do that. And then we'll come back here. I think we'll have some time to, do some work on the volume driver API to get things set up for the cycle. And then we'll do some priority discussion. But that's basically it. So please sign in on the Etherpad just so we can track your colors as you leave comments. Do the usual thing. Comments in the Etherpad are preserved. And that's it. Okay, Gorka, you can take over the screen share.
Thanks. Let's see if it works. Okay, it works. Awesome. That is good.
It looks nice too.
So you used the same thing I did.
Template, yeah, that's what I thought when I saw your slides. Like, hey,
Consistency, I love it.
Yep. So, okay, well, here we are once again talking about quotas, because why not? Hopefully, this will be the last time we have to bring the topic to PTG. So, yeah, quotas have been a pain point for Cinder users forever, at least since far as I've been in Cinder. And the degree of pain depends mostly on the size of the deployment and how the deployment is used. But it basically ranges from not painful in small deployments with infrequent requests, all the way to hating all the Cinder developers and their ancestors for the large deployments where people have a lot of problems and they have different projects, and their quotas, yeah, basically. So I brought the topic to a PTG because our customers, even I see Brian laughing still. Okay, that's good. So because our customers, even after all this time, have not learned to love the inner beauty of the Cinder quotas, and they want the quotas to actually work, which is weird. And since customer is king, and I didn't have much luck with the dice roll, I've been cursed to fix them. So, for that, I would like to discuss the possible solutions and get to some kind of consensus here on what we prefer to do before I actually start working on the spec and the code. So to get as much participation as possible, which I know it's hard because it's Friday and this is quotas, I'll do a very quick overview of the Cinder quotas and its problems, and then introduce some possible solutions that I've noticed on this solution, because of course there are issues. Well, that should be enough for anyone that is here and is not familiar with quotas to be able to contribute to the discussion. At least that's what I hope. And feel free to interrupt me at time when I'm talking to if something's not clear, or if you want to add something I missed, or basically if I say something that is wrong. I'm sure that the idea of quotas is not foreign to anyone here. There are limits on the amount of resources that a project can use. For example, for volumes, we'll have limits on the number of volumes and the gigabytes a specific project can have. So if we want to create a 100 gigabyte volume on the LVM type, Cinder will translate this into a quota request for one volume and 100 gigabytes. And to know whether we are within limits, if Cinder processes this request, Cinder has to look at the current usage as well. And right now, Cinder stores both the limits and the current usage in the database as fields. So given the limit, the usage, and the requested values, Cinder can determine whether it accepts the request or fails right at the API, giving the users a quick response instead of having to wait or look at the logs or the user message. In this example, the request is rejected because the number of gigabytes would exceed the limit. What an admin can do here is just increase the gigabytes limit, and then the check will actually pass. But the thing is that in Cinder, we can also have per volume type limits. And when defined, they are usually more restrictive than the generic limits, and their in-use values are also different from the generic values. So we also have to check this. So not only the generic, but also the per volume type, because it can block the operation from happening. That's the general concept that we all usually have in mind. But in reality, also Cinder also has to take into account that operations take time to complete. They are not automatic or atomic. They go from one service to another, and between the quota checks and finishing the operation, another operation can come in, complete and consume the quota that the first operation thought it had. So to prevent these race conditions, we have reservations. Let's look at an example. Let's say we want to increase, let's see what we have. Okay, so we have increased in the previous example the gigabytes limit that was blocking. So now that operation can actually come in and it's going to create the volume. But we are still in the API, so it's processing it. And now an extend on a different volume is received. So now we want to extend another volume to 100 gigabytes by 100 gigabytes. Sorry. Okay. Okay. So now we would get the reserve. The create would not be committed, so it's not part of the quota because it's an ongoing thing. So it goes into reserve because that operation wants to reserve 1 volume and 100 gigabytes for their operation. And the new request it doesn't require volume because it's an extend, so 0 volumes, but 100 gigabytes need to is the quota request from that operation. Now we do the checks and surprise, surprise, it fails, of course. And the way we do it is basically an addition. We check the database, what is the limit, what is the quota, the in-use, and the reserve, because reserve is also in the database, and then check against the request to see if it passes or not. What else? This is basically the general idea of the reserve and how we operate. But then when you look at the Cinder actual code, it's a lot more complicated, fortunately, because there are a lot of little details that it has to account for. For example, the limits, they may exist or may not exist, the per volume type. Maybe they are not, so it has to actually check if there is something to look for or not. Then the current values for in-use and for reserve, the row in the database may not even exist because maybe we just created a volume type and we have never created a volume before for that type. So it also has to check, and if it doesn't exist, it has to create it. It's more and more details that makes the code a lot more complicated. And then we also have the fact that something can go wrong in the middle of the process, so the operation never completes because the Cinder code, let's say, it's broken somewhere. So we not only increment that counter of reserve, but we also have a different table, which the reservations. And that table has a timer, let's say, when the operation has to be completed. If not, we assume that the operation has failed and we delete the reservation from the table and decrease by the proper amount the corresponding counter. As you can see, not non-trivial, all this stuff. So what is the source of pain for Cinder users? If you ask me, I would say that the problem is that they know math, and that is the problem. So when they run Cinder quota usage command and see that the in-use and reserve values, they see them, they add them, and they see that the actual number of volumes in the database, in the database in a Cinder list doesn't match. They kind of get angry, or they are not happy, or the operation cannot proceed because it exceeds the limit, exceeds the limit without actually having when it shouldn't exceed it. So if math it's a problem, let's use it to solve the problem. Kidding. What Cinder has as a workaround is for this issue is basically a feature that can look at the existing value. Every X request looks at the existing value, erases the in-use value from the database, and write the current count in the database. This is a sync that you can configure to do it, and this is the workaround we currently have. Possible. By default, I believe this is disabled. So why do quotas go out of sync and why do we need this? Well, there are multiple reasons. Some of the known ones are incorrect tracking of temporary resources, which recently we have tried to improve because previously we were doing hacks around it. Now at least we have a feel to say this is a temporary resource. Don't need to do anything about quota with it when you delete it, for example. Another one is we sometimes forget to commit the quota. So we have the reservation and we forget in some specific code paths to actually commit the reservation, remove it, and everything. We also have bugs in the synchronization code. And even sometimes we have unexpected failures in the code that end up creating this problem. I believe that we may even have race conditions within the code, so a little bit of everything, let's say. But in the end, I think the main problem is that the Cinder code is complex to get operation from one service to another, so it's hard to remember all the possible paths from different services that can reach a specific point in the code. And the quota code is not simple. As I said, it has to take into account a lot of little things, and the spread across the Cinder services doesn't help. In the I create the reservation here, but it doesn't get committed until who knows when. So let's jump to the main topic here, which is what are the possible solutions here. One solution is just to fix what we have. So I could go through the code and analyze it to make sure it doesn't have race conditions, that all paths do what they should be doing, and just fix things. We can call this the whack-a-mole solution because it's basically that, go around fixing things. And yep. The next one is one that it has been previously discussed before, and that is to remove this counting in the database and do things dynamically. So we would count the resources, the volumes, and keep and use this to change the database instead of counting quota, in-use quota, and reservation. There is an old spec that was not approved in a POC that implements it. This basically, the spec and the code comes in here. Well, it's kind of a copy of something that was done in Nova a while ago. So this is one of the possible solutions. The second possible solution, the last one, is basically we remove also the quota and the reservations, and we do a more complex SQL that does the conditional update of the in-use. Sorry, we don't remove the in-use. We just make it happen everything in SQL. So the engine, you tell it, I want to do this. It does everything, and we would have it in our SQL Alchemy -api.py file, and it would do everything there. Now, for these last two solutions, there is an issue, because at least in the counting, in the spec of the counting, and in that implementation, that POC, we were only looking at the easy cases. For example, create on delete, volume, and snapshot. Those were the cases that we were looking at and discussing, saying, oh, this is simple. We can just remove, count the volumes, count their size. That's done. The problem is that this doesn't account for some of the more complex operation, complex in the terms of quota, not because they are difficult. For example, the extend operation. This is complex in terms of quota because you cannot increase the size of the volume you are changing until the operation has completed, because if it fails anywhere in the middle, you would be storing a wrong size there, and you would no longer have any idea what the actual size. If I'm increasing from 1 to 2, the API has to check it, say, okay, it's good, let's proceed. But it cannot increase it automatically to 2, because then the Cinder volume service would not know what it has to change and what it has to do. So here is why this is one of the reasons why we cannot just remove reservations altogether. Another operation that it's kind of complicated is the retype with migration. The retype in general is problematic, but it's fast. In some cases, it's fast. When you have a migration, it's slow, so there's a lot of possibilities, things to happen in there. And the problem is that you want to temporarily consume quotas from 2 different volume types. You don't know if you're going to fail, so you cannot just free the old one and start consuming the new one. You have to kind of reserve or keep using the one you're using and reserve the other one, but you don't want to touch the size. You don't increase the number of gigabytes in terms of quota, because that should not affect the user. You should be able to migrate a volume even when you have no more gigabytes in your quota. So, and before we start discussing solutions to this, so we start discussing the solutions in workarounds or how we can solve these issues I just mentioned. I would like to see if anybody sees additional issues here in the quota and these 3 solutions, or if anybody says, hey, why don't we do this other solution that it's even better? I know that in the past, for example, for the counting, there have been people complaining, oh, this is going to be a performance issue. There are going to be performance issues because now you're counting. Like I think it was Eric said, that's what databases do. But that's the main point of a database. They are good at doing that. If you create your indexes correctly, they will count fast. That's fine. And after all, if we remove the reservations, some of the playing with the quota increase and the reservation increases, we're removing also requests from the database, so kind of a trade-off.
But I think, Gorky, you actually just hit on one of the major problems, is that, yes, databases are designed to do counting really well if the indexes are correct. getting those indexes correct is the hardest thing. And if they are wrong now, fixing them is an even bigger issue. Having to refactor a whole database and redo the indexes can be a complete nightmare, and you need a real database expert to make sure that it's correct. And I don't know whether we've got any of those in this team.
Well, I know somebody. I can ping Stick from SQL Alchemy, and he has helped me in the past with a problem that we had with conditional updates, because my SQL does something that doesn't follow the SQL standard. So I had trouble figuring it out, and he helped me in the past. So maybe I can ping him again.
Yeah, these are a complete nightmare. I know that. I've seen many instances over the years where an index is out just really slightly, and your performance is a quarter of what it should be.
Yeah.
You know, and finding that one tiny thing is a massive effort, and you always wonder at the end of it whether it was worth it.
Well, one thing that I can do, which is not, even if I don't know if it's the best indexes, I can do a comparison. I can hit like the API, just the API with a lot of requests, and see that and do the comparison in terms of time with the new indexes and see how it compares.
Yeah.
So that it doesn't degrade, at least it doesn't get worse. Yeah. Even if I get his help and everything. But yeah, that is definitely something we should add to the Etherpad to make sure if to console.
I think we discussed this counting mechanism with Nova last time, and they are doing it. Like they are dynamically counting database records of resources, and they don't face any performance complaints from anyone. They mentioned that. So
yeah, well, the thing about Nova is, and a lot of the APIs in OpenStack in general, is that they're all pretty slow. And when you start talking about comparing them to the backends that we manage and maintain, our APIs are much, much more responsive. And the number of customers I have who say, why is OpenStack taking so long to respond to creating a volume when I can see on the backend array it's created in half a millisecond? Why are the API responses from OpenStack taking so bleeding long? And I don't have answers to that. And it's always, to me, seems that the APIs are incredibly slow. And I'm sure it's down to the complexity of the code, that all the loops we have to go through.
I think for that part, there are a couple of things that I've noticed as well. And for example, due to the abstractions in us sometimes coding a little bit fast, we sometimes do multiple requests to the database when one is sufficient. We kind of, that is something that I have planned in to analyze actually what requests we are sending to a database, to analyze if it makes sense to do that many. Because from time to time, I'm reading the code and I see that we are reloading something that we had already loaded in the version object, but because we refactored the code, we didn't realize that it was already loaded, and there it goes, another request. And that takes time. So I think that doesn't help either. So besides being careful and considering consulting with an actual expert to make sure that the indexes are right, let me also add and do a comparison with current performance. Anybody has any other possible solutions or issues that they think they either have experience with the quota or that I missed?
Trying to think of an edge case that you may have missed, and I can't think of one.
The solution I've been kind of inclined to do is the counting, but with some modifications. So the idea would be we remove the in-use and the reserve counters, but we still keep the reserve table. That way, when we do the database counting, we can actually count the reserve, and we can even account for which ones are no longer valid. We can do that automatically, and if we do that, we can also, I would like to remove the reservations in every single case that is not strictly necessary. For example, for creating a volume, we can just decide, okay, any volume, any database record of a volume will count as a real volume, even if it's in error, as long as the scheduler has set a host in the database, for example. Or we can just say, whenever we create a volume record, it counts as a used volume by that user. That's it. So we don't have to do the reservation for those cases. It's not temporary volume, it counts. If you don't like it to count, delete it. That way we reduce the number of cases where we have the reservation dance. And I think it will probably be better. And for the extend and the retype with migration, we would be doing it, the reservation. We would actually create the record, because otherwise we cannot track correctly those numbers. That is the solution I would like to go with, and it's going to do it right. I think it's going to require a lot of changes in Cinder, because right now we are doing a lot. Well, we have a lot of things mixed, and I don't know how I will go about implementing this for the rolling upgrade, because if we didn't have rolling upgrades, it would be a lot easier. You stop everything, you bring it back up, and it's doing the new thing. That's fine. But if you have rolling upgrades, suddenly your services with the new code comes in, but they have to live with the ones that are still using reservations for everything. And that's where it gets a little bit trickier. The solutions are, I find a way to make it be able to start, and while it's doing the rolling upgrade, it behaves as it used to. And the other solution is say, yep, while you're doing rolling upgrades, your quota may get messed up. Those are the two options.
But for that second option, you then still have to have a simple way of resynchronizing after the rolling upgrade.
For the simple, you don't need to resynchronize, because you're going to basically stop using the whatever it's in the in-use and reserve. You're going to ignore it altogether. You're just going to use the reserve table, and that was being already maintained by the old code.
Okay.
So I don't think that switch is going to be too difficult. If we go with the other solution, with making something a little more complicated that can live with the old code, and while it's in the rolling upgrade process, can use the old quota mechanism, that means that we could even set a configuration option to say, don't use the new quota, use the old kind of usage, in case somebody finds that everything is completely broken and unusable. They can say, okay, better the devil I know. But what I would like to avoid is for us to do like we did with the nested quotas, like have two mechanisms for a long time. So if we decide that we move to a new counting mechanism, I would like us to commit to it. Sure, we can leave a failsafe in case a deployment has problems and we fix it or whatever. But I would like to say, okay, but we are deprecating the old one. You could have a failsafe during one cycle, but on the next one, this is going to be gone. Because otherwise we are going to have to maintain two pieces of code, and this is code that nobody wants to work on it because it doesn't break anything. Your data is still there. You can just go into a database and fix it, so nobody ends up working on this. So if we have to maintain double the code, it's going to be double bad.
I guess my thought is the people who aren't seeing problems with the current system won't be seeing problems with the new system anyway. So we don't have to worry about them. And then the people who are seeing problems, I think they might accept some weirdness during an upgrade if they're going to get something better or even just different, right? So,
yeah, I think I agree, Brian. And also, when people do rolling upgrades, they tend to do them at times of minimal activity. No one's going to risk doing it during a big period. So people probably quiesce the whole environment anyway.
yeah, that's a good point.
Okay, that's good.
Yeah, so I think, anyway, so I think making the transition is a good idea and not worrying about carrying over the other code.
Need to make sure that it's well documented in the release notes.
Right.
Yeah. Okay. Okay. So then I'll start working on a POC with these two cases, and for example, a delete volume and create volume so that we can see what it would look like and start working on the spec. So
Okay.
we can.
All right, that sounds good. All right,
And
great.
we need to jump, right, to the other meeting.
Yeah, so we have to go to the other. So the other meeting, if you're interested, is Secure RBAC. We'll probably be there for 90 minutes. There's a link on the Etherpad. It's in a Zoom meeting. I have to close my Blue Jeans because I can't have them both open at the same time. But it shouldn't hang us up. I'll just leave a note on the Etherpad saying that we're there. So see you there. Otherwise, we're scheduled to be back here at 1500. So if you have no interest in Secure RBAC or it's giving you a headache while you're there, feel free to just leave and come back and meet us here at 1500.
Give me
All right.
a headache just thinking about it.
Yeah. All right. Thanks. Okay. I'll see you in a bit.
Well, all right. See you there.
Okay. See ya.